Well, good morning, everyone, and welcome to today's Research Pays Off seminar. I'm Jerry Geib. I work at the Office of Materials and Road Research here in our research section. And today's speaker is Professor Ashley Buss from Iowa State University, and she will present on the chip seal program in Oregon. So you will summarize the performance and methodology used for developing specifications in a chip seal design in Oregon. The test sections included both emulsified asphalt and hot applied chip seal applications. Pre and post construction pavement performance information is presented and analyzed. The post construction analysis of the chip seals includes macrotexture analysis and dynamic friction testing to measure microtexture and pavement performance surveys. Underlying pavement conditions were classified from being very good to very poor. A comparison of field performance on test section is developed to recommend best practices and develop a rational design methodology. Please welcome Professor Ashley Buss.
Thanks, Jerry. Good morning, everyone. Today I'm going to talk about a lot of the work that we've been doing in Oregon with their chip seal program. This started off as a research project in 2014, and it's kind of continued on, and now we're in a phase 2 where we have a STIC grant, and it's a federal grant where it really focuses on implementation. So we've taken the research from the phase 1, and then now we're kind of in an implementation phase and implementing some of the specification changes, and I'll talk a little bit about that today. First off, I wanted to acknowledge the co-authors and everybody who's worked on this project. Anytime you're going to make a big change, it's almost a cultural change in the agency of how they do chip seals. It takes a lot of people to help steer the ship. So I wanted to acknowledge Doug Ransberg, who's done work in chip seals for many years now, and he's well known in the industry. And then also Chris Williams, and then my PhD student, Mina Skirgis. She'll be graduating this summer, and her PhD work has been mostly all on this project. Other acknowledgments is, of course, the Oregon Department of Transportation, especially John Lazarus and Larry Ilg, the binder suppliers and the chip seal contractors have been instrumental in providing their input and helping us with anything from the construction phase to their thoughts and experiences of what happens around Oregon on the roads and best practices that they use for their chip seal contracting. And then also Paul Lecce, Ben Claypool, Marie Chenois, Jesse. These are all students who went out and collected field data. And in the phase 2, anytime you're working with specifications and making big changes, we have a big team that always gets together to provide feedback during that specification change process. Because anytime you change specifications, it affects a lot of people. And the more people that you bring to the table, the better the outcome and more things you're thinking about as you're changing those specs. So just to give you an introduction, going back to the phase 1, why do we even start down this path? We wanted to document some of the different methods of chip sealing that Oregon was using, namely the emulsified and then also the hot applied seals. We wanted to look at how these chip seals were performing, and then also if there's a way that we could use chip seal design to get better performance. And then from that data, from those results, identify best practices for implementation and see what we could change in the spec that might make the chip sealing program in Oregon better. So just to give you an introduction on the benefits, the benefits are the improved cost of the effectiveness of chip seals by increasing performance, better roadway surfaces, safer roadway surfaces, making sure that we have good texture on the chip seal roads. And the integration of a rational method. So by looking at the chip seal design process, is there a way we can move that forward to the field so that there is some rationale behind those application rates, and not just, oh, this is what we did last year, it worked pretty good then, and because things change over time, road conditions are changing, and is there a way that we can rationalize that for especially new inspectors that haven't had 20 years of chip seal experience? So there were some retirements happening, some changeover, and some pretty new people on the jobs, and we wanted to provide a rational method for them to actually set application rates. So getting into the types of chip seals that we looked at for this project, it was usually the single layer seals were predominantly studied, and that made up most of what Oregon's putting out there for chip seals. There's the hot applied, and then the emulsified asphalt seals. And these are some pictures of the construction process as it was happening. And all of the seals that were used in this research, they all use polymer modified binders.
Hey, Ashley?
Yeah.
We still see the first slide.
Oh, you don't see it's not advancing?
No. You may have to present it a different way. Did you click on the present desktop, or did you present the PowerPoint in the Skype meeting? Because PowerPoint in Skype is really slow.
I did the desktop.
So you may need to minimize your screen to see your slides.
Oh, are you seeing the desktop?
Okay, now I see. It still might be a little slow because this is actually, you've pulled the PowerPoint into the Skype meeting, which tends to be very slow. But try going to the slide. Oh, that worked.
This works? Okay.
Okay, perfect.
Okay. So yeah, let me know, chime in if there's any other technical issues. Hopefully it'll advance now. But with the types of seals, that we have the hot applied and the emulsified asphalts, single layer seals. Can you see my mouse?
Yes.
Yes, we can.
Okay. So we have the single layer chip seals, and then all sections use the polymer modified asphalt binders. And so these are just a couple of the pictures from the chip seal construction process. So for the general chip seal material information, my background's really in materials, and so we wanted to collect a whole bunch of information about the materials that we were using. But when we got all the materials here, started analyzing them, it's kind of interesting. We had relatively similar aggregate sizes, with the exception of Unit A down here. So I'll talk a little bit more about each of the sections, but relatively similar aggregate sizes. We had really similar micro Duval results, so our anticipated aggregate polishing was about the same. We had some seals constructed in 2014 and some in 2015, and I'll talk a lot more about the 2014 sections. And this is kind of the traffic profile in the graphs down here. We have the average daily traffic on the y-axis, and each of the units, and the units down here in the yellow, these were the emulsion, and those tended to be placed on lower volume roads. And we have the hot applied over here, and we had a pretty good range of different traffic volumes that those were placed on. So now I'll talk a little bit about the unique climate of Oregon. So we had some different projects. The Klamath Falls was the main test section area. We had a lot of different types of seals down. We had 2 types of seals down there, kind of similar traffic conditions, and a whole bunch of sections to take a look at. And as you can see on the east side of the state, we have really high and dry conditions, and then as you go west, you're going to run into some of the Cascades region where you get a lot more rainfall. Then you have the valley, the Corvallis, Eugene, where a lot of the population live, and then over here on the coast, you have some really heavy rainfall situations. And what's interesting is their chip sealing window, especially up in this region, is pretty short. It's a pretty tight window that they're able to get in there and do the chip seals. And part of the problem of that very short window is it's the highest tourist season too. So you have Portland here, which is a pretty big population base. Everybody wants to go out to the coast, and so you're trying to chip seal in your highest traffic time also. So that can be a challenge. So these are the various sections that we had in the project. Some of these stars represent several sections. Units A through H down here at Klamath Falls represent a big portion of the project. And to kind of give you an idea, Iowa, so if folks from the Midwest, Iowa, we get about 36 inches of rain a year, so we're kind of in the similar to what the valley would get. And then, but just a huge difference. You're tripling that up in the northwest region of the state. So huge differences between the climate. Like I said, we took a look at the aggregate gradations. We especially looked at the performance uniformity coefficient. How uniform is that aggregate? How many of those stones are going to contribute to aggregate loss? And then on the flip side, how many of those stones are going to contribute to aggregate bleeding? And so we graphed that. Unit A had the least uniform chips, but at the same time, it was a really angular, clean stone. So although it wasn't quite as uniform, it was a clean, very angular stone, and it wasn't too bad to work with. And then the rest of the aggregates are relatively low uniformity coefficients. With our chip seal performance, we characterized the existing pavement conditions. We ran pavement condition surveys, and the Oregon DOT, they have their pavement management information system, so we were able to get more general ratings from that. And we took a look at the chip seal surface characteristics at 1 and 2 years after construction. So with the pavement condition surveys, we took the cracking information, the rutting, and just overall general condition of the road. And then also when we came back after the chip seal, we took a look at the microtexture that we used the dynamic friction tester. So that's a machine that you're able to do a spot test on the microtexture. And that really gave us an indication of the microtexture of these aggregates. So how are those?
Sorry, I think we're one slide behind.
Did that help?
Didn't move. What should we be? What should the title be?
Chip seal performance.
Yeah, we don't see that. Can we try? What'd you do last time? Minimize? Or did you kick up your PowerPoint? Or
Share screen. And here's the presentation.
no? We're still seeing this same slide. Can you minimize the Skype window and see if we can see the PowerPoint behind it?
Okay. That's minimized.
Not here, is it?
Did that do anything?
Nope, we're still looking at the same screen.
Yeah, I'm not sure what's going on. I just have it in presentation mode and I'm advancing the slide.
The video, maybe it's moving slow because the video is going.
It shouldn't.
Not just using the PowerPoint presentation, don't use the presentation mode, just using the PowerPoint.
So you're in share screen right now, and you've minimized the Skype part.
Yes.
Okay, we're not seeing that for some reason. This is a new one for us.
Yeah. Let's see.
Try not to use the PowerPoint presentation mode. Just open up the PowerPoint.
That's what she says she's got on her screen, but we're not seeing that. I guess try turning off your video.
Okay, I'll switch to audio only.
Yeah, that didn't work.
Are you getting video or not anymore?
No, we're not seeing video, but
Okay.
we're still looking at that same slide.
Yeah, I've minimized it. I've taken the.
Do you see that button at the top that says Stop Presenting?
Yes.
Maybe you should click on that.
There we go.
Okay, now we're back in the Skype window.
Okay.
Um,
And then try it again.
yeah, try that.
I'll try share screen.
Yeah, try share screen and then open up your minimize and then open up your PowerPoint.
Are you seeing it?
Stop it.
It's coming, but I think. There we go. That looks better.
Okay, that works.
Yeah, you can probably turn your video on again. Right now we're looking at map of all there we go. General chip seal materials information. That's what we're seeing.
Okay. Did you see this slide yet?
Yes.
Yes.
Okay. And then I'll advance. Okay.
Yes.
So now we have all the chip seal locations, and so this is new, right?
Yep.
Okay.
Saw that before.
You saw it.
Yep.
Oh.
Saw that.
Okay.
One more.
All right. So chip
Now
seal.
you can now you can turn your video back on.
Okay, I'll try. Well, I got to exit out of the.
Never mind then.
Yep, we'll just keep going. Okay, so with the chip seal performance, we were characterizing the existing pavement condition. And so I wanted to talk about the microtexture and the macrotexture. So microtexture is really going to be a function of your aggregate characteristic, that surface texture of the aggregate itself, whereas macrotexture is going to be more of a characteristic of the number of aggregates that you have and the uniformity of their size and how embedded they are into the asphalt. So that's really an important characteristic of a chip seal because you can tell a lot of things by it. So macrotexture is really the key thing that we were able to take a look at here. So it's determined by the size, shape, and the relative spacing of the aggregate particles. And to measure the macrotexture, we use the mean texture depth, and New Zealand has a very nice specification that's quick and easy to do with. It's very inexpensive, and we use it's called the sand circle test. It's very similar to the ASTM sand patch test, and except for in the ASTM you're using glass beads, whereas in the New Zealand method you're using a very tight gradation of sand, and that ends up being a lot cheaper, and you can just leave the material on the roadway. You don't have to try and sweep it back up. So in general, the higher micro and macro texture, there's kind of an interplay there, the better the skid resistance. And there's some really great reports that have been done about measuring the trends between micro and macro texture and having that relate to skid resistance. We didn't get into that too much in this study because on the dynamic friction tests or the microtexture measurements, they were really seasonally affected. And so we think that there needs to be a better way to standardize those results, and they're pretty sensitive to seasonal variations. So we didn't get a lot of really great consistent data with the microtexture results, whereas with the macrotexture, we got pretty consistent data over time that was consistent across the sections, and then it matched up pretty well with other national level research that's been done. So I just wanted to show some of the performance survey results. And what was kind of interesting here, we had the bleeding, and it was really confounded to the pre-seal condition of the roadway. And so we have some confounding effects here. Unit B here, 2 years after the construction, we had quite a bit of bleeding, but this one had the highest severity fatigue cracking and those higher severity longitudinal cracks. So that was probably a culprit in the bleeding. And then also up here, Parkway and Prairie Road, these were the sections in Eugene, and Eugene's a little bit of it's a little wetter climate compared to the Klamath Falls region. And some of the contractors mentioned that the further east you got, the hot applied seals didn't work quite as well in those regions because they are a lot wetter, and we had some bleeding in those areas. Also, they were close to Eugene, so we're looking at higher traffic too, which might have been a factor in a little bit higher bleeding in those roads. And then the chip seal loss. So this is purely a chip seal distress. You've got the Unit C. There was some patching done with that one, so we think that was what the problem was there. Unit E, we had some aggregate loss, and then in Unit G. So these are all the sections in the Klamath Falls. Now, with the chip seals, we have the two major distresses, right? We have the bleeding and the chip seal loss. So that's kind of the two main things that are going to go wrong with the chip seals. But also, I think it's pertinent to take a look at cracking data too. Not that a chip seal is going do you a whole lot of good as far as fixing the cracks, but its purpose is to seal the cracks. So we took a look at the sealing of those cracks. Is the chip seal covering up the cracking that's out there? And so with the transverse cracking, at year one, where the solid orange bars are, you can see a pretty big reduction in the transverse cracking. And then those tended to come back at year two, but they're still at a reduced level. So what we're seeing here is so transverse cracks are working cracks. You're going to have quite a bit of movement. Those are sealed up for at least 1 year, and then they tend to come back after about 2 years, depending on the severity level of the crack. Then with the longitudinal cracking, usually those aren't moving quite as much as those transverse cracks. And those went away a lot more. So we had the road all sealed up, and then had a pretty low incidence of return. And then I also wanted to talk about over here on the right side of the graph, where we had no cracking in a road, we didn't ever see additional cracking. So I thought that was kind of an interesting contribution of the study of looking at these sections sort of crack by crack, looking at the severities, and then seeing what's returning out there. And this is really about the type of binder that you're using. So is the binder going to be able to bridge those cracks? Is the aggregates are they going to stick there and have those cracks sealed up for some years after the seal is actually placed? So we ran the stand circle test to look at the macrotexture trends. The aggregate retention and resistance to bleeding are both evaluated by the macrotexture. The larger circles indicate lower texture. So the larger circles here, those are in the wheel path. And the smaller circles here, they're off to the edge. So that would be not in the wheel path, and you get smaller circles, so you have higher texture. And this is kind of just a diagram from the New Zealand's specification of how mean texture depth is measured, and the equations that you can use to determine the average texture depth. So taking a look at what happened over time, start here with the pre-construction condition, pretty low texture. Right after the chip seal was placed, you have a high amount of texture, and then a reduction over time. And we wanted to take a look at the performance specification that New Zealand's actually using. And so what they do is at 1 year, so we're focused in right here at that 1 year mark, they go in and they have an equation that uses the chip seal design life, so how long they expect this chip seal to last based on the amount of texture there, and they can also use that in programming new chip seals into their budget. And so they come out at 1 year and compare the measured value versus the requirement. And you're able to tell here that we well exceeded the requirement. And this was Unit A, this was an emulsion, used a CRS-2P, and we had a 0.48 gallons per square yard. And then this is Unit B and C. These had some rougher pre-construction pavement conditions, so some pavement deficiencies there to begin with. The mean texture depth was wider range to begin with, and after the chip seal, it looked pretty good. After 1 year, it looked pretty good, and then after 2 years, it got a bit lower, but it still would have passed that 1 year performance specification. And this is just another way to look at the data. So you have the mean texture depth, and these are box plots of the statistical data that was taken in the pre-construction texture condition. After construction, we have between the wheel pass and in the wheel pass, so you have a little bit of variability there. After 1 year construction, things kind of even out, and you have this deterioration curve that you can see happening in the sections. Now we took that and compared it to the measured texture minus a statistical variance. So we want to make sure that we're statistically above the measured texture, and then compared that to the minimum texture requirement that New Zealand uses. So this is where we're getting into the idea of, wow, we think a performance specification might work pretty well for Oregon. And Doug had done a lot of work in this area. This was published in 2010 in an Oklahoma study that Doug had been working on, where they studied the mean texture depth over some period of time, and they were taking the measurements in very tight increments. We were just doing yearly measurements, whereas Doug was out there monthly taking texture measurements for the Oklahoma study quite a number of years ago. And so I was curious of how our Oregon results would compare with the model that Doug developed in his Oklahoma research. And interestingly, here's that at construction, 12 months after construction, these dots are just averages of the mean texture depth of what we were getting. And our aggregates lined up it was all pretty similar. And we have that, we follow this curve pretty closely. So what this means is that this deterioration model, it is, you can use it in other places. And what's really important are these trigger values here of, you don't want the chip seal to fall below a certain texture depth. So as that texture is deteriorating, you can use trigger values to determine, okay, how far out, once I put a chip seal in the program, how long does it take for me to actually, from where I program a chip seal to get it constructed? And you can use this deterioration model to back out and program your chip seal budget accordingly. So I don't want to spend too much time on preservation programs, but I think as we took these results of what we were finding in the chip seals, that as we move forward to change specifications, that we take a look at what Oregon has compared to what the best practice recommendations that Federal Highway provides. So the first one is adequate dedicated funds, and with that, Oregon kind of has an interesting cycle of where they have an on year and an off year. So hopefully in the future they'll be able to even out the work a little bit more and have more sustained funding in the chip seal arena, and not have 1 year where you do a whole bunch and then the next year where there's hardly any. So and then also effective marketing of preventative maintenance, and I think that's just starting to communicate the results, the good performance that we're seeing in the phase 1 research, support from management, legislative support, training and buy-in of workers. So I mentioned there had been some folks retiring and some new inspectors in ODOT who hadn't had as much experience with chip seal. So bringing in some of that, the design and how that happens is important. And then the public awareness of financial benefits of preventative maintenance. And there's a huge cost savings for chip seal that's extending that road life. So as we started determining what sections of the specifications we wanted to look at, I took a look at some of the literature and looked at some of the challenges that have happened with pavement preservation specifications, just in general of what's happening. One of the main challenges starts with the project selection. So making sure that you have a chip seal, especially if you're going to put a performance specification down on a road, making sure that that performance specification gets applied appropriately to the appropriate project. And then materials, making sure that all the materials pass spec. And then there's a workmanship component of, are you putting everything down on a prepared surface? Is the weather going to cooperate? And then also specifications. So not only having good specifications is important, but making sure that those specifications are enforceable and following up on if there is a performance spec, following up on that and enforcing it. So all of these things interplay to develop a good, successful chip seal program. And then with a performance spec, so the big thing that Oregon wanted to do was get out of the business of setting the application rates. And so we're kind of taking a method spec, reworking it to have it be a performance specification. So that means we need to have different risk profiles, and that should ultimately change based on the pavement condition. So the worse the pavement condition, the agency needs to be taking on more risk, and the better the pavement condition, then the risk can be shifted more to the contractor. And then there's always that in between too, where you've got some shared risk profiles also. Some of the specifications that played a huge role in the research is the New Zealand, their P17 chip seal performance specification. If you haven't looked through it, it's really an interesting program and an interesting way to do a performance specification. There's design guidance. They have a really great manual all about chip sealing and the history of chip sealing in New Zealand. Another thing that was helpful is Michigan's chip seal warranty specification. They provided clear visual inspection expectations. And what we wanted to do is, as we were writing the specification, make sure that an inspector can take that clearly worded visual expectation and then apply that to the seal. And then Michigan also has really good conflict resolution guidance. And then also with the design guidance, the Minnesota Seal Coat Handbook has been extremely helpful document, a great resource. And another one that's not on here, but I can see Oregon wanting to use it a little bit more in the future and maybe create their own similar document, is Idaho's chip seal warranties guidebook that has a lot of different pictures of various chip seal distresses, and then also examples of great chip seals too. So some of the major specification changes that we're moving forward with is removing the application rates. And this is really a culture change between taking a method spec and then using a performance specification with the macrotexture requirement. So in the new specification, the contractor would provide the material test, and then they would design the rates of the chips in the binder. And moving this from a prescriptive to a performance specification, That's going to change the risk profile. It'll change the role of the Oregon DOT inspector on the job site, and it'll change the initial, we'll have an initial inspection at 2 weeks where there's a visual inspection, and then a final inspection at 1 year. So in the performance evaluation, there's a visual inspection that takes place at 2 weeks and 1 year. Then at 1 year, the macrotexture trend over time is looked at, and then also the variability in the macrotexture tests will also matter. So major specifications changes would be a 1 year maintenance period for the contractor, and then it would be anticipated that that's going to be built into the price of the bid. The pay schedule is going to change, and that's one thing I think as far as things that'll really influence how easily the specification will be to implement is that the details on the pay schedule. Retainage really isn't an option because the contractors have to pay their material suppliers, and there's a little bit of profit margin, but there's not a huge profit margin that retainage can be absorbed. So the bonds seem to be the best way forward, and it seems that's how most states that with warranty bonds, that's how they are able to do the bonds on the chip seal. We wrote in the conflict resolution team into the specifications. We think that'll be a good way for if we do have major chip seal failures. It's a good process for contractors and agencies to work together, build a team and a task force to figure out what went wrong and how do we stop it from happening again. And then another big change would be the pay item. On the emulsion, especially the emulsion chip seals, we noticed that the application rates for the chips, the aggregate, was being overapplied quite a bit. And we kind of wonder if there's a little bit of a chicken and the egg situation here where you've got are they putting down too much binder and then they have to compensate by adding a lot more aggregate, or are they putting it down too much aggregate? But there was a lot of there's a lot of aggregate placed on the emulsion sections when we compared it to when we back calculated out what a design rate should be. And so that gets into how you should change it. And we had a lot of conversations about that, and we settled on the square yard as long as there is a performance criteria that has to be met. So it's a pay item change to square yard, but also in place with that performance requirement. So I mentioned the role of the inspector is going to change. With the old specification, we had the inspector was actually setting the application rates. So they had an active, more directive role in the process, in the construction process. In the new specification, it would be more of an active observer. They take the observations, times, temperatures, actual rates that are applied, and use these notes at the 2-week initial inspection, and then again at the final inspection. Another thing is the inspector, we want them to share any concern with the contractors at that time while the contractor is there. And if there's any problems with the chip seal, we want repairs to be made as early and as soon as possible, because it's easiest to make the chip seal repairs while the contractor's there. And then once we set that if we implement the macrotexture specification, this is just an example table of what the requirement for macrotexture would be, given we have traffic, various traffic up here, and then this down here in this column we have the average least dimensions, so that's a function of the aggregate size. And there's other parameters that go into this, but I used kind of an average of what we had on the seals that we were using. And all of the sections that we looked at, they passed. So it'd have to be a pretty catastrophic failure of a chip seal to not pass the specification. But we think it's a good way to see that once we're out there 12 months after the construction, that we have a good seal and that it's going to last for some time. The sand patch test would be performed on 5 different spots across the lane, and then the average would be taken as well as the standard deviation, and so that would go into that macrotexture would be compared to these numbers here. So this is just a flow chart that we developed. It's a I would call it a work in progress, but we have the chip seal process, the bidding process, kind of the project planning stage. And then when we move over here, we have the construction. Then there's the initial acceptance. There's the maintenance period, and then finally the final acceptance. And so it's kind of a work in progress, but we've been working through how to implement the performance specification and also so that it's done in a way that we get everybody on board. So I just wanted to wrap up the phase 1 findings. Overall, both seal types helped and showed an improvement in the pavement condition. The seal-related distresses were visible on some hot applied sections, but those sections also had the worst substrates, or that worst initial pavement condition. Dynamic friction test data, we had consistency between the sections, so trends between section A and section B. We would see the same trends over time, but we saw some really inconsistent values between years. So things were kind of up and down, and like I said, the seasonal variation with the test on the chip seals, it didn't really work very well. And then all seals passed the New Zealand performance specification at 1 year. And what we really wanted to do was, with the performance specification, is when we do have a chip seal that fails catastrophically, is there a way that we can have something written into the specification where ODOT can recoup some of that loss? And right now with the method specification, there's really not a good way to do that. So that's spurred some of the change, and it's not that they have a lot of chip seals failing. They have a lot of really great performing chip seals, but it's just that the ones that do fail, it seems like those are the ones that everybody remembers. And so putting this into specification, I think it's going to be a good thing for both the contractors and the agencies that you're able to, you can even use it as an incentive. So we've brainstormed ways of incentivizing good chip seal performance too with the performance specification. And then finally, the emulsified chip seals tended to be over chipped, and the hot applied chip seals, those seals match design rates very, very closely. So phase 2, with the specification changes and implementing the phase 1 findings, it's really been an open dialogue about changing the specifications. We've had a lot of meetings, and bringing more people to the table and changing those specs has worked very well. It's a large shift in culture, and so that's taking time. The payment retention isn't really going to be practical for contractors. And so because of that, we're continuing to work with performance specification and implementation. We're looking at options with bonds if there's a way to do that, and work with the kind of the higher ups and other offices within ODOT to figure out what we can do from a financial aspect to get the performance aspect of this written into the specification. So with that, that's my presentation. This is Eastern Oregon on the top, and I'm happy to answer any questions.
Hey, Ashley, this is Bob. We've got one question online about, I'm not technical, I'm going to have to try this again. Were the transverse cracks sealed prior to construction? I think that's what it says. Let me see if I can pull it up here. Oh, were the transverse cracks sealed prior to chip sealing?
I don't think they were, because they were the teams that were out there, the boots on the ground folks taking those measurements. They didn't mention that they were. I think one section and I think one section in the Eastern Oregon in 2015. I think that some of those had some sealed cracking, so that they didn't register as higher severity. But in the Klamath Falls, it wasn't mentioned that those were sealed, so I don't think those were sealed as much for the Klamath Falls section, which makes up a bulk of the research. When you do seal cracks, though, the seals need to be placed at least several months in advance, but preferably the year before.
Actually, what was the typical age of roadways that were sealed in the study?
What was that?
I'll repeat the question. What was the typical age of the pavements?
Yeah, the original pavement.
The original pavements.
That information, I never was able to get a hold of that. I didn't have the construction history on these pavements.
Were they fog sealed at all?
Were they fog sealed?
Yes. Yeah, the fog seal made them, it sort of locked in the aggregate, and it made the seal look really nice.
Got another question from the audience here?
So you had the deterioration model from the monthly measurements, and then you superimposed your yearly ones on top of it. Can you go to that slide?
Sure.
So the idea would be, instead of just, okay, I guess we probably don't need it. So the idea would be to do this macrotexture measurement depth, and then use that as a way of determining if the chip seal needs to be applied. And my question is, approximately how much variability do you get, and do you think those 5 measurement locations will be enough to assess the performance?
So yeah, these were just with that deterioration model, they were just overall averages, and I was kind of just playing around with the data to see how it lined up, and I was really surprised at how well it lined up. However, for each seal is going to be a lot different, and you might have a deterioration that are you able to see the slide still?
No.
Okay. But depending on what that underlying pavement condition is, you can get pretty rapid degradation of a seal. because of underlying pavement condition. However, with the data that we had, these roads, the average road that the seals were applied to, they were pretty good candidates for the chip seals. So I would say this figure is, the deterioration model is best applied for roads that are good candidates for chip seals. And so I would, that deterioration model, I would, if you have a questionable road, I would proceed with caution in using it. Now, for the 5 seals in one area, that would be for the passing of a lot. So there would be the passing of a section, and then within, there'd be so many sections per lot, and then there would be so many lots per chip seal project, depending on how many miles were being constructed.
Okay, so you'll have more than those 5, because you showed like a diagram with 5 locations where you run the test, but you're saying that's 5 locations per lot within a project, so you'll be able to use multiple lots when you're making your performance decision.
Yes, exactly.
Okay. That makes sense. Thank you.
We've got a couple more questions online. Oh, quite a few. Did you see a difference in crack reoccurrence between emulsion and hot applied seals?
We did a little bit, but I think it was more the underlying pavement condition. And the biggest performance difference that we did see, the bleeding was the big one. So the bleeding only happened in the hot applied seals, and I think there's 2 reasons for that. Is we had a lower amount of chip applied on the hot applied seals, and we had higher traffic on the hot applied seals too. For the cracking, it was just a little bit too variable to say that we have a statistically significant difference between the reoccurrence on the emulsion versus the hot applied. It was really, really tied to that underlying pavement condition.
Okay, another question is, has your area experienced any pavement stripping on the chip sealed pavement? Do you experience a significant freeze-thaw cycle like we have in Minnesota? And in Minnesota, there's a huge issue, and many cities and counties have gone away from chip sealing as the result of stripping issues. Either way, do you have any insight on stripping in chip sealed pavements?
In talking with the contractors, the wetter the region that you get to, especially with the hot applied seals, they had mentioned some problems with having stripping happen, especially with hot applied seals constructed late in the season. And so that's been a little bit of a problem. But with the sections that we had, the only major problem that we saw was in one situation where that I would really call it was more of a loss of an aggregate. I don't know if it was necessarily stripping, but the aggregate was gone. But it was over they had some wheel path patching that had happened in one of the sections and chip sealed over that. And then on those patches, we lost a lot of the aggregate on the wheel path patches. So that was kind of a problem that was particular to that roadway section. I don't think that Oregon's, especially the eastern side of Oregon, they could chip seal quite often, and they've got a huge chip sealing window, and it's dry out there. They're going to get great results. On the east side of the state, you have to be really careful because it's a really wet environment, and yes, you do see some stripping issues, but I haven't heard of it being a huge problem as much there.
Okay, another question online was, how many different paving contractors were represented in the study?
At least 3, and then plus ODOT, because there were some ODOT constructed seals too, and then in our writing our specifications, we have I think it's 4 different contractors, and then 3 different binder suppliers that have been involved in the various meetings that we've had for specifications.
Okay, I think this is the final question, which is, does this study, or will this study, consider the double or triple chip seal applications?
No, we've really focused in on single applications, and to keep it simple for making that culture change from a method spec to a performance spec. I could see it in the future that especially double seals, because sometimes what'll happen is with the single seals, you'll put it down, and then you want a different texture, and so a year later you can come back and put that double seal on there, and you'll get a nicer, more uniform texture after a year. I was talking to a gentleman from New Zealand, and that's what New Zealand's really gone to, and they've had really good results with that. So we've talked about that approach a little bit in our meetings, and to me it would make a lot of sense too, because Oregon's a big bicycle state, and the rougher the texture, the harder it is on bicyclists. So anything that you can do to kind of maintain that roadway race surface, but then have an approach, which would be that double chip seal, to even out that texture a year later, it might be helpful for roads that see more bicyclists.
All right, well, that's all the questions we've got. I thank you very much, and thank you for your patience with our technology, everyone, and you too. Thank you very much, Ashley.
Thank you.
Just a reminder that our pavement workshop is in a little bit more than a month. Encourage you all to register. And this afternoon, actually in about an hour, our own Bernard Izabakai will be presenting in a TRB webinar. So if you're interested in concrete, he'll be talking about aggregates and base, I think, on that. Thank you very much.